So dear students, good afternoon. Today we are going to discuss about the methods of preparation. That is different methods which are used for the synthesis of amino acids. So far in the last class we have seen in our first session just what are amino acids, what are the general formula of amino acids, uh, how they exist as a sweeter ion, what is isoelectric point, and what happens if if amino acid is added again with an excess of acid, and what happens to amino acid if it is reacting with a base. So we have seen different points, and we have also have seen the pH. What happens at a certain pH that migration does not take place and where the concentration will be maximum. Okay, so these are some important points we have discussed in our last session. Today we are going to discuss different methods of preparation. How we use different methods for the preparations of amino acids. So in these methods of preparation, in according to your syllabus, there are some important portions are there where you need to learn these equations for your examination sake, and in point of answering your questions in the examination, you need to know certain methods of preparation for the amino acids. So in this session we are going to study session 2, methods of preparation. Methods of preparation. According to your syllabus, you have to study methods of preparation first for the glycine, alanine and phenylalanine. You have to study first for the glycine how to prepare, and you also have to study according to your syllabus alanine how it is can be prepared through different chemical process, and next one is phenylalanine. Okay, now we will be seeing what are their general formulas, how they are. We know, all of us know the chemical formula of glycine is, it is the basic amino acid which is having H2N CH2, the first amino acid. I meant basic means the first amino acid which has a general formula H2N CH2 COOH. Here one basic group is there, one acid group also is there. Again you have another one, alanine. Alanine has a general formula that is CH3 CH NH2 COOH. This is another amino acid called alanine. Again what happens in the phenylalanine? Phenylalanine, one instead of one hydrogen you have one phenyl group, that is benzene ring CH2 CH NH2 COOH. So the short forms of glycine is usually written as the symbol of glycine is gly, alanine symbol is ALA, phenylalanine symbol is PHE. So now we will be seeing different methods how to prepare amino acids. Okay, we will be seeing the first one is preparation of glycine. First one is preparation of glycine from carboxylic acids. So the first method of preparation is preparation of glycine from the carboxylic acid. Glycine is, we know that. Okay, so first preparation is preparation of glycine. From carboxylic acids. Okay, there are carboxylic acid that you get. All of you should remember that whenever you are writing for your examination point of view, you need to write a sentence plus equation. Sentence carries 1 mark and equation carries 1 mark. It involves 3 steps. acid first is treated with the acid is converted into alpha halo acid by means of Helmholtz-Zalonsky reaction. Again, alpha halo acid is treated with ammonia, and next the ammonium hydrolysis of ammonia. So in this preparation there are three steps. First step is acid is converted. We are preparing from a carboxylic acid. We are preparing this amino acid from a carboxylic acid. So first in your hand you have a carboxylic acid where the acid is converted. First you have to convert acid converted to acid. Whatever you have in your hand, that acid should be converted to alpha halo acid. Alpha halo acid. That means, what is this alpha halo acid? Suppose if you have an acetic acid, that is CH3COOH, and this is the acid group, it is the functional group, and again you have one methylene group here, methyl group. So in the methyl group, hydrogen is an alpha hydrogens. Okay, suppose this is called alpha position. This is called alpha position. That means the group which is next to the functional group is called alpha group. For example, if you have another chemical formula, that whereas CH2, CH3, if you are having, so this is called beta carbon, because functional group has one, there is a functional group, and there is one carbon attached to functional group. There is one carbon which is attached directly to functional group. So that carbon is known as the alpha carbon. This carbon is known as the beta carbon. Again, here if you write CH2 and if you write another CH3 here, that is known as the gamma carbon. So first, whatever acid you have in your hand, that you have to convert into alpha halo acid. That means alpha position of hydrogen can be replaced by, hydrogen should be replaced by halogens. Halo means halogens. What are the different halogens we have? We have different halogens, that is chloride, bromide, iodide, fluoride. These are different halogens. Instead of hydrogen, you have to replace it with a alpha halo acid. Okay. Next part B is again alpha halo acid. The product what you have in your hand, that is alpha halo acid. It should be converted. It should be reacted with, treated with ammonia. Okay, again the product, whatever you get this product, again that product is treated by hydrolysis. Okay, this product on hydrolysis, you get alpha amino acid. So let us see what happens here, the reaction we are going to see. Chemical reaction, very easy to simply, I am teaching you, I am not giving you the stress or anything to learn the mechanism, because for chemistry main students only we give mechanism. You can simply learn this equation. So our first step is acid should be there in your hand. For example, you have an acetic acid in your hand, that you have to treat with halogens, that is you have Cl2 in the presence of phosphor. Cl2 in the presence of phosphor when you treat. For example, what is the mechanism here? For simplicity's sake only I am showing. This mechanism is not at all compulsory for you. But to know how this is happening here, you can write CH3 as a CH2 hydrogen. Okay, then you have C double bond O OH. Okay, now this you have to treat with the chlorine. Chlorine means Cl. Chlorine means you have a 2Cl. Cl2 is there. So when you treat with Cl2, okay. So this is the Cl. Cl2 exists as a Cl. So what happens? One chloride is more electronegative. Suppose you take one electron this side. So this Cl becomes a negative charge. Automatically this Cl will be carrying a positive charge. Here hydrogen will go as H plus. Hydrogen will go as H plus by giving these electrons here. So H plus will go and react with Cl minus, Cl minus, and here you have a bond pair of electron where it is C will be carbon will be carrying a negative charge with a pair of electron that will react with the chloride. So as a result you have a product after reacting here, that is HCl plus CH2 Cl C double bond O OH. So this is called alpha halo acid. This is called alpha halo acid. Okay, now alpha halo acid you have to treat with the ammonia. You have to treat with the ammonia, that is 3 molecules of ammonium you are treating ammonia. So what happens here? Here one molecule of ammonium chloride will be eliminated. This hydrochloride will be eliminated by giving you H2N CH2 COO COONH4 COONH4. Again this COONH4 you will be treating or doing hydrolysis. You are treating with hydrolysis. Then you get a product that is H2N CH2 COOH. This is glycine. This is glycine. So this is one way. This is called actually getting amino acids from the carboxylic acid. Again another synthesis there for alpha amino acid. Okay, that is Strucker's synthesis. That is called Strucker's synthesis. Here also you will be treating Strucker's synthesis. STRECKER synthesis. Strucker's synthesis. Okay, in Strucker's synthesis, first aldehyde plus HCl aldehyde plus HCl and ammonia. HCl plus ammonia will give you aminonitrile. Will give you aminonitrile. Again this aminonitrile only you are hydrolyzing. You will get amino acid. So here in the first process you are having the starting product is acid. That means you are converting acid into amino acid. Here you are converting aldehyde into amino acid. That is called Strucker's synthesis. Now we will see what is the chemical reaction. Okay, we all of us know aldehydes have a general formula. Functional group is CHO. So let us take one aldehyde. Now you can take acetaldehyde or any other things. So for example, if you are taking acetaldehyde, this is the acetaldehyde formula CH3CHO. So this is acetaldehyde, basic aldehyde. Now you can take, instead of hydrogen one R group, that can be CH2 or amino group, CH2 group or CH3 group or phenyl group, anything can be replaced here. So instead of one hydrogen you will be taking R CH2 C double bond OH. This is C. Instead of one hydrogen you are replacing with the R. This you are treating with the hydrogen cyanide. Let us see what happens here. When you are treating with the hydrogen cyanide will be actually existing as H plus and Cn minus. Here you have again carbon double bond oxygen, where oxygen is more electronegative than carbon. So the pair of electrons can be attracted by the oxygen. As a result, here you have R CH2 CO minus hydrogen. Okay, since the electrons are shifted from carbon and oxygen to completely to the oxygen, then what happens? Here carbon will be carrying partial positive charge. Plus you have hydrogen cyanide, where a hydrogen cyanide is existing as H plus and Cn minus. So here the combination takes place. Here one positive charge, one negative charge will be attracted. Again here one positive charge and one negative charge will be attracted. As a result, you have here R CH2 COH. Here hydrogen is there as it is hydrogen. Since here carbon is having a positive charge, sorry, here a small mistake is there. I forgot. Here carbon only is carrying a positive charge. So carbon only is carrying a positive charge. So Cn minus will be bonded to the carbon as Cn minus. So again this on treating with the ammonia. So what happens here? Treating with ammonia, you will have R CH2 CH NH2 Cn. Okay. Again, this compound is called alpha amino nitrile. Alpha amino. That is alpha. This is nitrile group, that is C triple bond N. Then this is an alpha carbon. In the alpha carbon there is a nitro group, so it is called amino group. So that's why it is called alpha amino nitrile. So again this alpha amino nitrile with the hydrolysis. You have an hydrolysis. So as a result you have R CH2 CH NH2 COOH. So this is called alpha amino acid. Okay. Now let us learn these two things first and we will come back for the next class. Okay.